I'm Charlotte Louise from Country.com, and today I'm just going to do a quick example of a problem of work. So, hopefully you've already gone over that work is equal to the force times the distance that it's applied through times the cosine of the angle that it's made at that distance. So this is a pretty common problem, which is just a block on a flat plane, and you're going to have a force applied to it and some amount of friction. And later on you're going to learn sort of how to deal with finding out the kinetic energy from this, but basically today I just want to go over the work that's done by the applied force and the work that's done by the force of friction. So here, if we're doing the work from FA, and we want to know how much work is done over, let's say, 10 meters. We're going to do the force, 10 newtons, times 10 meters, times this distance. We bring it up through the force. The angle between those two is just 0. So cosine of 0, which is equal to 1. So right there, we have 100 Newton meters, and work is measured in Newton meters, or joules, which is unit-wise equivalent to joules. So that's pretty easy. That's the work done by the force applied. And then for friction, so just super quickly, for friction we need to know the normal force. We know that the force of friction is equal to mu times Fn. So I think always, here we have a flat plane, so you probably have done enough problems to realize that the weight is equal to the normal force to have equilibrium where the block isn't like suddenly jumping up, which obviously wouldn't happen. And if you haven't done enough problems to just sort of be able to look at that and see, I definitely recommend practicing before you take any sort of test. But it's good to just draw this out, because as soon as we get on an inclined plane, we don't have that equivalency where we can say the normal force is equal to mg. So I just draw that out, and then here, then we know that the force of friction is equal to mu times mg. So that said, then we can do the work due to friction. So work from the force of friction is going to be equal to the force, which is mu times mg, or 0.2 times 5 kilograms times 9.8 meters per second squared, because we're dealing with all SI units here, times the distance. So we're still looking at, we want to see how much work this is doing when we travel those 10 meters. And then cosine of the angle. Here, this is the direction that the force of friction is moving us. So when we look at that with this distance, really it's being applied 180 degrees from that displacement that we're going. So here, we're going to have cosine of 180, and that's going to be -1. And that makes sense. This is doing work against the way we're moving. So that can be easily calculated out. And then we'll have the work from the force of friction also. Yeah, so that's just a basic way to find work.